Welcome, folks, to a new video of the series Discover EWM MFS, a video series where EWM meets automation and I try to explain different topics, different functions of SAP EWM MFS. As with all the other videos, this one is created in cooperation with Swisslog, provider of automation hardware and also EWM integration services. And if you want to get more information about those services, feel free to check their website. I'll put the link in the description, and I will also put open positions in the description in the area of EWM development, consulting, and project management. Today's topic is task interleaving. So basically we are talking about a tool, a feature, a functionality, or a logistical process within a warehouse which is used to increase resource efficiency. I will look at it from the perspective of manual processes which are supported by SAP EWM. So I will recap and explain again how task interleaving is supported by EWM in manual environments before I jump into the main topic of this video, which is task interleaving for automated storage and retrieval systems. The approach is slightly different. We will look at the main differences, and then we will also look at how it is configured in EWM MFS, and also at the technical details, like how it's working on a technical level. We'll have a quick look into the code, and then at the end of this video you should have a good understanding about how it works, what needs to be done to make it working, and where we have the differences to the manual area approach. So this is what I told you, and we will skip that one. And as I said, we will start with a quick recap of the approach for manually operated environments. And if you want to get a comprehensive, detailed description about this, then I would recommend going back and have a look at the video to understand task interleaving in SAP EWM, where I really go through this step by step in every little detail. So let us take one practical example to explain the manual approach again. We have a warehouse, and we have a staging area for shipping and receiving, and we have a pallet rack. And you just assume that you have forklifts operating here, doing the put away and the removal. And in a simple non-interleaving environment, you would have let's say you have one forklift driver doing the whole put away stuff, so taking pallets from here and put away here, and then just go back, grab the next pallet, put away the next pallet, take the next one again and again. So this forklift driver would do the put away movement, and another forklift driver would do the removal movement. So driving in the aisle, grabbing a pallet, staging it, grabbing the next pallet, staging it. So each forklift driver would have half of its movement with load and the other half without load, so coming back to grab the next pallet without load. And the idea of task interleaving is now to combine those movements. So basically you have one forklift driver doing the put away, and before starting to drive back, he would grab a pallet from the rack which has to be removed, and grab it and go back with this pallet, stage it here. So no empty movements at all anymore. And the objective from process, business, and logistical perspective is to minimize the travel distance and thus increase the throughput overall. And that should be it as the explanation for the process as such. And in manual areas, you have to define different queue types now in customizing. So in our example, you would have two different queues here, and we would assign those queues to two different queue types. With these two queue types, you then assign to the resource group, like if you would assign any other queues to resource groups, like along with the sequence. But in addition to this, you now define a queue sequence for the queue types for the resource group. So remember the previous screenshot, the queues were assigned to two different types, and now we also sort the queue types. And based on this, we'll later have EWM sequencing the task. So whenever you complete a task from a queue type in, EWM will switch and give you a task from the queue type out next, and the other way around. It will always flip, respectively go through the sequence. And that's the whole story for manually operated areas. As I said, there is a comprehensive video explaining the whole topic in detail. We will now right away jump into the automated environment. So as I already announced at the beginning of the video, the approach is different here. And it is different to the fact that we have one queue assigned to one resource. Before we go into this, let us quickly talk about the practical example and the environment that I took here. And you just simply assume for the next minutes that you have a high bay with a crane operating in one aisle. So this is our automated storage and retrieval system for this video. One aisle and one crane and pallet movements into the aisle and out of the aisle. Very simple. Yeah? So what do we need to do in order to activate task interleaving in this environment? First of all, you need the MFS resource type, and this resource type is later assigned to the resource, which is our crane here. And for this resource type, there is one tiny little flag, and that's the whole story. That's the whole customizing in terms of task interleaving for automated areas. And in order to understand this, and in order to understand how it is working, you might think that the SAP help would give you some information, but the only thing that the SAP help tells you here is actually what task interleaving is, and not how it is implemented in EWM MFS. So it just tells you, okay, we want to avoid the resource traveling empty, so instead the resource is given a new stock removal task before it returns, blah, 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 blah. So we will reduce the number of empty trips. That's what I explained in the beginning of the video, but that does not help us to understand the approach that EWM takes here from technical perspective. So in order to understand that, we start looking at the customizing and the application data, and then we will look into the code. So we have a resource type which is activated for task interleaving. In addition to this, we need the MFS queue, and this MFS queue is defined via customizing. The operating environment needs to be MFS, and then it is assigned to a resource, and this is done via the application data, via the easy access menu, via the transaction SCWM MFS underscore resource. And you see here, each resource has exactly one MFS queue assigned to it, the one that we assigned in customizing, as well as a resource type, which is carrying the interleaving flag. Based on this, you already see we only have one queue, so we cannot apply this approach that I explained in the beginning for the manual areas, where we define a sequence for different queues, let's say put away into a retrieval queue, and then switch between those queues based on the sequence. That's not possible here because we only have one queue. So how does it work? And again, as with some other topics, the only way to understand this is to look into the code. We will make it simple. I don't want to lose you here and make it too complex, but we cannot avoid this deep dive here. We start at function module SCWM MFS WT-DET. You might be familiar with this one in case you watched the other videos from this video series where we discover EWM MFS, because that one is the essential and the important one when it is about selecting a task which is to be sent to the subsystem. So selecting a task for which EWM wants to create a telegram and share this telegram with the PLC. And so whenever a task is created or confirmed, this function module is called in order to decide what is the next task which is to be processed. And in this function module, we have a subroutine check resource. And in this subroutine, we call this function module here, which reads the resource type from the given resource. And this resource type data, which is read here from customizing, the customizing that I showed you before, this is carrying this interleave flag. So you see here the structure that we took from customizing along with the interleaving field, and this is written into the variable EV endleave, and that becomes LV endleave in the calling program, which is our WT dead function module. And so we are back at WT dead, and we know now whether interleaving is to be executed for the resource type or not. This information is now sitting into within our LV endleave flag. And now the next thing that we need to decide is what is the direction of the next move. And this variable is now filled with a 1 in case picking is supposed to be the next move, and it is filled with value 2 in case put away is to be the next move. And the decision, picking versus put away, is now taken in subroutine check interleaving. And we will now look into this subroutine in order to understand how this decision is actually being taken. The secret here is the determination of the direction of the last movement, because we can only decide about the direction of the next movement in case we know what was the direction of the last movement. If the last movement has been a put away, we know the next one is to be a retrieval. If the last movement has been a retrieval, we know the next one is to be a put away. Because with interleaving, it's all about keeping this circle running. Put away, retrieval, and minimize the distance which is being traveled as empty. The approach is pretty simple. The thing that EWM checks here in this subroutine is basically what is the current bin of the resource. EWM always keeps track of the current bin of the resource, and imagining a crane doing this put away and retrieval movements, the crane is either at a bin within the MFS storage type, so in our example it just dropped HU at a bin within the rack, or the crane is outside the rack at a drop-off position where it hands over a pallet to the conveyor. That means that we know for sure we are either at the storage bin or at the conveyor handover point. And the thing that SAP does here, it just reads communication point data here with this function module, TMFs CP, so communication point read, and hands over the actual bin of the resource. And then this function module returns communication point data, but it only returns communication point data in case a crane is at a crane to conveyor handover deposit position. If the crane is at a put away bin within the rack, this function module will not return any communication point data because put away bins in the rack are not defined as communication points in EWM MFS. If you want to understand what a communication point is, I would recommend this PLC EWM integration video, which I will link here in the video header. The question which is answered here, is my current position a communication point? And if yes, the last movement has been a retrieval task, because we are right now at the deposit bin of the crane, and if not, the last movement has been a put away task, because we are within the rack. And this actual bin, this is taken from the resource itself. EWM always keeps track of the actual bin of the resource whenever it confirms a task. We know now about the direction of the next task because we just determined the direction of the last task, and we just take the opposite direction for the next task. Pretty easy, actually. And that means that the last remaining step here in this function module is to figure out which task is the chosen one. So we know the direction, but we don't have the actual task yet. So which is the one that gets a telegram and is being processed by the subsystem in the following step. And this is done again, called from MFS_WT_det, subroutine select WO. So this subroutine is selecting the next warehouse order to be processed. And within the subroutine, there are many bodies where you can implement your own logic. We will look at the pure standard now. And we already learned that LV int leave now carries a 1 or a 2, telling this subroutine whether the next task is to be put away or retrieval. What we do here, what EWM does here, then is taking the table LTWORSRC_TY, and this table has all open tasks for the given resource. And this is sorted in standard based on the latest start date and the priority here. The queue is not really relevant because we only have one queue for the resource. And then here, EWM evaluates the value of the LV int leave variable. So if it is 1, we search for picking as the next task. If it is 2, the coding would be here, it's cut on the screenshot. If it's 2, it searches for put away as the next task. And it selects the task based on the direction, and the direction is actually taken from the content field of this internal table here. I show you on the next slide where it is coming from. And then on step 3 here, it appends this warehouse order that it just took from the table to a collection of preferred warehouse orders. So here you see it loops over this table, so it takes the first ones based on the sorting that I mentioned above, LSD and priority. So it does it 15 times and just adds warehouse orders from this internal table which having the preferred direction. And it decides based on the content field, and this content field, as I said, is taken from this SEWM WO_RSRC tie table, which is carrying all warehouse orders for a given resource. And the content field here has a couple of different values, but interesting for us is it holds information whether the warehouse order is a put away or picking task. I won't go into detail here about how this is being filled. It happens way before, during warehouse order creation. But for us, it is important here that we decided whether we want to do retrieval or put away. Then we took this whole bunch of possible warehouse orders for the given resource, sorted it based on the latest start date, and then select the most urgent ones based on the content field and our interleaving variable 1 versus 2. That's basically it in terms of interleaving and task collection, because this subroutine then hands over this table of selected warehouse orders. As I said, there are up to 30 tasks within this table. 50 for put away, 50 for picking here in a given sequence, because EWM wants to make sure even if one of the tasks at the top cannot be processed due to some whatever locking reason, I don't know, that there are some more in the buffer which could be taken. But at the end, it just grabs the first one from this internal table and then tries to create a telegram for this one, which is then finally done by function module MFS send. And again, for those of you familiar with this video series, know what's happening here. This function module is responsible for converting a warehouse task into a telegram which can be processed by the subsystem. I would recommend the video for EWM PLC communication in case you want to understand all the details step by step about how EWM communicates with the subsystem and sends telegrams to the subsystem. Not in scope for this video here. And we actually covered everything at this point already that I wanted to communicate in terms of task interleaving, so it's time for a quick summary from my end. What you should take away from here is that interleaving for automated storage types, so for example for automated storage and retrieval systems, is activated based on the resource type and customizing this tiny little flag, remember? And every resource in an MFS environment is working with one queue. So this flip-flop approach that you know from the manually operated areas, where you bring 2 queues or more into a given sequence, and then EWM switches and flips between the queue types. Actually, the types are in the sequence. This is not possible here. So the approach is slightly different, and EWM simply takes the current bin of the resource, which helps to determine the direction of the last movement. Based on this, determines the direction of the next movements. And then from the pool of possible warehouse orders, it derives the information from this WO resource type table, which gives the direction of the warehouse orders, and EWM compares the direction of the warehouse orders in the pool with the direction from our interleaving flag, which had been determined based on the current bin of the resource. And that's basically it about task interleaving in automated storage and retrieval systems. As usual, everything is available as a blog post on my website also. Feel free to take the content from there, take the graphics and the pictures. I'm happy if somebody benefits from what I'm doing here and takes some value out of it. And I'm even more happy if you want to get notified about new videos. So subscribe to the channel, click the bell. And if you are interested in additional services in terms of EWM integration, feel free to visit the Swisslog website and get in touch with their EWM team. Having said that, enough for today. Hope to see you next time again when I release the next video, and happy learning.